I guess if I'm going to record, I'm going to share it too, because that way it's in the recording. So let's see. What I was imagining we might do is just kind of, hey Jack, talk about the all the parts and steps that go involved in this. Like we had said, I'm trying to page back in what we said at the end of the last meeting. We said that we wanted to kind of approach it a little bit from two ends, maybe extract some things from rustc and extract some things from, or Chaco's already extracted, I guess, but bring the two a little closer together until they can be actually unified.
Yeah, so I mean, sorry, it was a little bit late. So I feel like we're pretty close in terms of things being the same. There's definitely some bits and pieces that we need to add and change, but I think the big work at this point is on the rustc side if we want to split out some things from rustc middle. And I think there's a few different things that we can do there, but I'm not actually sure how much all has to come out at once.
Yeah.
If that makes sense. Because I don't think we could extract out tie without extracting out like type foldable or the other way around.
Yeah. So what are the differences to be reconciled? There's like
so
the type, like the folding, the visitor traits are a little different.
Yes. So I guess we should maybe discuss at some point if we still want to try to push for the chalk type version where we have the visit result, or and if it's needed, or if we want to go the rustc route of keeping with a Boolean or the control flow.
I would be inclined to do, like, given that we're not using the chalk one for anything, like even maybe that's because we haven't landed. I know I wanted to do counting, but I don't remember what I wanted to count. And I kind of think that that became less important. If I have a vague memory that I didn't need to count anymore once we changed over the binding system so that it's counting binders and not counting variables. I think that's what I wanted to count, was like how many free variables are in an expression or something like that. And they kind of didn't matter when you didn't have to introduce that many corresponding number of binders.
Yeah.
So, and it's just, it's just more complicated and harder to understand and going to take more monomorphization and all the things. So
Yeah, and I sort of agree with that. Especially because I mean my biggest gripe with the Rusty version was that it used a Boolean. But if we're switching over to control flow, I think the break versus continue makes a lot more intuitive
yeah, the
sense.
Boolean was always kind of confusing, but
so I would be on board with switching chalk to use like a control flow.
yeah.
So control flow is in stud, right?
I don't know what that
But
is.
I think it's in stud, but it's nightly, if I remember correctly.
It sounds quite.
Maybe not.
Maybe it's not stood.
No. I think it might have been recently added to nightly.
Yeah.
It's not in rustc yet.
Yeah. So I guess the question there, do we just duplicate the type for now?
Why not?
I don't think it's bad if we want to for now.
Yeah, I think we just do.
Okay. So yeah, that makes sense. If we want to just change type visitor and chalk to use control flow.
I think type folder in rustc is by value.
Yeah. Well,
it will be.
It will be.
yeah, LQDs or the LQD, whoever it is. No, LCM or LR.
Yeah.
That name. Their PR hasn't landed yet, probably, but yeah.
Yeah, I think that'll actually it'll be nice. And I think it should be. I don't know how difficult it'll be in Chalk because in Rusty there's no sort of interner, right?
Yeah, we have to do a little cloning, but I think it'll be all right.
Um, yeah, I think it should be fine. But when you bring up by value, we should also talk about at some point the tie kind by reference versus value.
Well, but that PR looks like it wasn't going to land.
It didn't, but I think that was because of the type folder by value. Or at least I saw a conversation somewhere of potentially retrying that.
It's also true that we can kind of undo one of these. Like, okay, so we adopted the type dot data yields a tie data, which has a kind field.
Yes. Yeah.
Chalk. But I don't know what rustc's current status is, but I think we moved to the method in rustc, right?
We moved to the method on, if I remember correctly, kind is on tie s, which is essentially the tie data.
I think, yeah. So I think like this method, which is no longer actually needed because, or it's debatable.
The alternative needs interner, right? Or
well, it's an interner. Sorry.
Yeah. So,
like, what I meant was that plausibly this this struct could become part of Chalk IR, basically.
Mm-hmm. Yeah, I mean, I was imagining that's essentially tie data now.
Yes, exactly. So that means we could always access the field directly and not via a method.
Right.
And that way, that kind of makes this tie kind thing not relevant, right? Because I think the problem was what was the return value of that function if that function goes away.
Right. Yeah, no, that makes sense. It also, so right now, the kind method in Chalk is on tie, not tie data. And it's essentially shorthand for the interner tie data dot kind.
All right.
So yes, I think if we need that kind method, it'll end up being on tie, which is different because in Chalk we have the sort of opaqueness, but in Rusty there's not opaqueness right now.
Yeah. What I'm imagining is, I mean, I think this might just stay the same. It's just that you might be able to do this in Chalk. Like eventually we would have a data struct that you can call also. Mm-hmm. Right now we don't, but I actually don't know what we have now. I'm guessing based on what you're saying because I haven't read that PR.
Yes, there is a tie data struct. It's essentially tie data is which interns rather than tie kind.
Yeah.
So the kind method calls data and just accesses dot kind.
I really wish we had oh well, whatever. I would like it if at some point we get some kind of accessors in Rust so that we could do this stuff in other ways. But I don't know. Leave that aside. So, okay, so I guess the question is, should we? It might be more convenient also in Chalk sometimes to match on. Like, there's an advantage to matching on the field, just that you don't have as much reference stuff going around, kind of. If you want to extract things by value anyway.
Yeah. Yeah, I guess I would have to look a little bit more into.
But in Chalk, we probably don't do that as much because we don't, this is an interesting question actually. We currently don't require that types and things are copied, right?
True, yes. So
We
we have all the like, if the intern version is copy, then you're a copy too, but we don't require copy.
Right. And that's useful to us because in our unit testing and stuff, we use arcs and whatever, but like it's also a pain in the butt because then we have to clone everything and things aren't copy. And I think that Rust Analyzer and rustc both use some form of interning such that types actually are copy. Maybe not for all the things though, maybe just for some cases. But it's plausible that we might want to require copy because we don't need that flexibility, and then we could just align the code bases a little more and have fewer calls to clone and stuff like that. No theory get optimized out, but
The
I don't
only
do this now. I just think it's a future consideration.
Yeah, the only thing with that would be how we want to deal with the chalk integration version, because that just wraps things in boxes.
Yeah, we'd have to make it using interner or something.
But that's probably okay. Yeah, we can figure that out.
We first get Rust Analyzer. Like I think you can't do it also because Rust Analyzer, at least today, is using Vex and things in some places, which we have to solve.
Yeah, we can cross that bridge.
What about regions? What other types?
Yeah, so regions. So Matthew's adding what is it? Refree and re-empty, or no, re-erased and re-empty. But we talked about refree, and that's also different right now. But I guess we're going to try to remove that on rustc side.
Yeah.
No.
What's the status, Matthew, of the lexical regions? I forget.
I don't think we can hear you if you're talking. I see your mic unmuting, but
I'm not talking now.
Oh.
Okay.
Yeah, but as I had said, I'm mostly sort of okay right now with adding what we need to chalk, and sort of as we move towards not using these.
Yeah, and also, isn't it easier to change it after we move things into the shared library?
Maybe, but I doubt it. Because there's not much, theoretically, not much logic in the shared library, so it's easy to add and remove new things, but not so much.
All right, it sounds like once we extracted it to a library, then it's picked up apart already a bit, so it's less entangled.
I mean, somewhat, but I'm not worried so much about removing, or I should say I'm not worried about removing things that we add to chalk because it's in rustc versus, I guess, not. Like I said, I'm sort of okay with just adding things to chalk as we need, because if we eventually remove them at rustc, I think it'll be easy enough to remove them in chalk, as long as we sort of don't build new logic around it in chalk.
Yeah, I think that makes sense.
Yeah.
And the regions in particular are, I think, really simple because like the restatic change was super small and easy. So I don't think adding regions will be hard. I think as was put here, param and perhaps re-early bound will be harder, because that actually requires quite a bit of logic.
Yeah, I'm not yet sure whether we want to change those things on the rustc side or what. So the type parameters is actually half the problem. The other half is, I guess let's separate this out, right? Region binders, and then there's Latebound binders. The stuff that you've been working on, Jack.
Yeah.
What's you've kind of got
What's
like
the
the first
status of that?
line.
Yeah,
so dummy calls and stuff like that.
Yeah, so a lot of the work I've been doing, so I've got it where it's actually sort of whenever you call binder binds, it'll actually sort of go through and visit all the types and then collect the bound bars. And the naive way that I had done that originally was just to count, but then locally I've also actually made it collect the actual ones. And there was a big performance hit. So I went through a bunch of places. We added rebind so that rather than sort of going through and visiting, it'll use the same bound bars, or at least in theory. Let's see. And then locally, I've also changed, gone through in a little bit more detail and basically audited all the bind calls to whether or not they're really binding or if they're dummy calls. And I've gotten sort of to a point that I've got all the easy ones done, but there are there's some bits that are a little bit more difficult once you start like lowering from AST that I haven't really dug into. I've also started to, so I also
I know the ones you're talking. There's some parts in the AST where they hear lowering or something you're talking about.
Yeah.
Okay, I can maybe help a little. There's some parts where I always hated that, although I wrote it, it's my own fault. But like where we keep we sort of know that there's a binder, but it's not very clear from the code.
Right. Yeah. So so I'm sort of at a sort of minimal subset in terms of bind calls that I am at this point, like I'm not focusing on that. Instead, I'm trying to make it so I had done for the variable kinds tie region const but also unknown for cases where rustc might skip binders. And so I'm trying to remove that. I found out that anonymized Latebound regions skipped the zero bound bar. But just
no memory of why that is.
Well, I mean, so I changed it and there was like 3 places that it basically does that. And then there's a couple test outputs, but I mean, the PR just got merged last night. So it's now at 0 and that fixed a bunch of cases. And there's now 3 test cases that are failing where there are bound bars being skipped that I have to look into. And that's sort of where I'm at. And then sort of once I get to that point, I want to do another perf run with sort of the current state of minimal setup binds and changing a bunch of the ones that seemed unnecessary to dummies and tracking bound bars. So it's so yeah, it's going along slowly.
Yeah, it sounds like you're doing awesome progress actually.
Yeah. And I mean, we can talk about this another time, but also it's sort of come up that like it's erase Latebound regions or erase regions returns back T rather than binder of T, and it doesn't do any erasing of types or const, and then anonymized Latebound regions won't respect bound types or consts. So I don't think right now it's a problem. I think those are called
Oh,
sufficiently late that there's not
oh.
going to be bound
You're
types.
saying, I see, it removes the binder, but it assumes the only things bound are regions.
Yeah, which
I think that just
Matthew,
wants to be erase late bound, period.
yeah. I mean, Matthew said that, or somebody said it. I think it was Matthew said it yesterday in chat that eventually it should be everything, and there's not really bound types. So it's not a
Yeah.
problem now, but it's sort of something to look at going
Yes.
forward.
Yeah, I think all the things that are specific, I don't think there's going to be a time, I hope not, where we want to instantiate just the like just one kind, you know, in their type theory sense of generic art.
And then I don't know if now's the best time to talk about it, but I was, you know, sort of after I get actual tracking of bound bars. So right now I'm essentially just mirroring the bound bars that are in the type as the list. But I think probably what would be nice here is to move even closer to sort of Rust or Chalk's model where we don't have all the different region kinds. We just have, or like the bound region kinds, we just have the anonymous. And then anytime that we need to know whether or not it's a named or BRM or et cetera, we can have the binders themselves. But I think that's a bit more of a ways.
I would like, it seems like if we can make it work, I like that design. I was a little worried about the performance, but.
I think it's I think it's possible because I was looking, and the only place that we actually like, from what I can tell, I'm not super familiar with the code, but from what I can tell, the only place that we're actually like checking whether or not a bound variable is like named versus m versus anon is in like the diagnostics. So as long as we're passing the bound vars to the diagnostic code, then it should be fine. But again, that's a bit of a ways away.
Yeah, that sounds plausible. We'll get there. So, din trait representation. So Chalk uses this like binder setup. rustc uses existential predicates or something. I like Chalk's better.
I think Chalk gets a lot of things right, but
so maybe we can migrate rustc over. I mean, existential predicates are just like an annoying version of what Chalk is doing, basically.
So can you explain a little bit more what this is? Because from what I thought existential predicate was just like a subset of predicate.
It is. It just doesn't have the self type. It's like instead of what Chalk does is uses the problem here is you want to express like din debug is, or what goes in here is basically a where clause but without the self type, right?
Right.
Because self type is not known, and so Chalk kind of just does that with a binder where you do have a self type, but it's this bound variable. Whereas in rustc we use essentially a duplicated version of predicate that doesn't have the self type. So, and is a little more limited because only certain things can be in din trait right now. So that is I guess a slight advantage in that it's not like totally generic, which then requires you to deal with a bunch of stuff that can't really happen, which, you know, is occasionally annoying. But on the minus side, you have this duplicated surface area where you sort of have the same thing, you know, and weird comments like this. And then like this function with self type kind of turns this existential trait ref into a regular trait ref by supplying self type. So that's kind of the same thing as in Chalk instantiating the binder with it. I think the Chalk approach is more elegant. It seems pretty clear. My only real hesitation would be the fact that this has this allows you to say exactly what goes in there, which might be useful. But maybe I have to think about it. Maybe there's Actually, rustc's approach to predicate is pretty annoying in lots of places. Like having the flat predicate there's all this random code where like it's only coming from the user and it can't have those cases, and you just get these bug arms and stuff.
Yeah.
So
not to mention the current state of for all is annoying sometimes. But
the fact that it's like one level deep, or
yeah, so the binders around so it's for all, which has the binders, but in like almost all the code right now, you're essentially skipping that binder and then rebinding it once you match, right?
Yeah, and that was it took us a while to find a setup that we were satisfied with, and even then it's not ideal. I know I like it better having the binders on every arm like we used to, but it is weird.
I mean, I think it makes more sense in the long run to think about having the binders over the whole predicate versus sort of each arm. But I think we're not there yet in terms of the code being clean enough for that to be clean, for lack of better phrasing.
Yeah. All right. So, I mean, it seems like we're concluded. We'll do some experimenting. And see if we can evolve how rustc is working here.
Yeah, there's a lot of big change. Yeah, I mean, like I said, I think a lot of this experimenting can happen as we move things into its own rustc crate to sort of align them. And like I said, I think that's where most of the work is going to be I should say that's where most of the refactoring is going to be, is trying to move things out versus sort of.
Yeah, so why don't we talk a little bit about that?
Yeah, so I was trying to think of what all is going to be moved out. And I guess it's going to mirror chalk.ir pretty well, I think.
I think so.
Because you have obviously like tie region const, type foldable, type visitor.
Yeah,
Subs, generic arg.
Like predicate.
Stock here. Yeah, it's kind of useless, isn't it? There's too much stuff to really get anything out of this.
Yeah.
Okay, so I agree it will mirror chalk.ir pretty well. I'm wondering what is the first thing. So, and I'm thinking about the interner a little bit. Are there going to be, one thing I'm wondering is, are we going to hit annoying, almost certainly we will, annoying coherence stuff.
Yeah.
Yeah.
Yeah, I imagine we probably will at some point, which is sort of why I said I think this is going to be the tough part. And I'm not exactly sure how much we can do this in parts versus just trying to start with tie, figuring out where you're running into problems.
How much does rustc use? Does rustc use proc macros for deriving foldable and all that stuff by now?
It does, yeah, in a lot of places.
Well, that's a question, is do we want to keep the like cross-family folding, or should we just simplify that? We didn't talk about that, but I think it's...
I don't think we really need it. But
what?
Can you
don't really need it, right? Or
we don't use it.
Oh, the target interner?
Yeah.
I'm kind of inclined to get rid of it, even though I love it.
I think probably get rid of it. I mean, it sounds like there's some cool plans for it, or potential plans, but I think it's easy enough to add it back. I never say that, but
I don't know what's going on with my like Bluetooth keyboard here, but I guess it's got a low battery or something. Yeah, I think my instincts are telling me it's going to go sooner or later. We might as well get rid of it now, even though it's the kind of thing that I always try to add and never quite pays its way in a
Yeah.
try it again the next time, and then I end up removing it. Like in the end of the day, it's often just a little too much annoyance for the benefit it brings is not quite high enough to deal with the number of bugs you actually fix. The other reason to get rid of it is that we're going to need to optimize folding at some point to do things like return the same value if nothing changed in some cases and stuff like that. And it's not that you can't do it with the cross-family folding, but you just have to add like an extra trait method to like do the casting, and it's kind of annoying.
Yeah, I mean, there's already a few methods of like transfer.
Yeah,
like,
basically, we already had this problem. I solved it that way, but it's just that much more stuff, and new users will be like, "What is this?"
Yeah. Like I said, if we eventually come up with a concrete problem where there's nothing else to do, then it might be worth adding back in. But I think for now it's fine to remove it, especially because I would rather lower the barrier to getting things merged together than try to add another thing that's maybe not even going to be used.
Yes. Okay. So we should remove that. The interners, I'm thinking about where, like in principle, the interner code should not have to go to the shared type library. It should stay in rustc middle. Because
yes. Yeah. I mean, the only thing with that is I think a lot of the places where we have tick TCX, it will be instead parameterized by on like interner.
So that's probably what we want. Like I think how I imagined this was that, let me just go down here to sketch. I imagined that we would have, I really shouldn't be using this keyboard. Hold on. Stop. Something like this.
Yeah.
Hopefully with less terrible names. Or maybe this would just be tie context actually. But and that, like, it seems to me like we probably want to try to do that refactoring actually. We don't even have to pull it out of the crate potentially. Like we could in rustc middle make a module with the type definition or something and try to pull some stuff into that module and actually refactor it so that it's generic over a trait that and then eventually that goes to a crate. That's probably the way to go. I don't know, maybe it's better to just put it in trait to begin with, but I'm sure my hunch of how this will work is that we will start doing that, immediately hit problems, git stash, fix the problem, and rinse and repeat for a long time until it actually works.
Yeah. I can't for right now see anything that's gonna potentially stop us. Just a lot of problems, you know, just a lot of steps.
So now I'm fantasizing about what if I actually tried to write some code. I'm thinking one of these two things I could maybe try to do. I had some ideas about this that I've now forgotten, but no one's like poked at this, right?
I did a little bit, but I did not get very far because I don't know a ton about it, so I didn't get very far. I think if anybody's going to try to poke at this, you would probably be the best person to.
Or one of them. That's my guess. Maybe Matthew too, but or Eddie B or something, but I don't think he will. It's fine, or they will. I might try to play with it. It would be cool if it worked. I would like the code better if we didn't do this trick. I'm worried it'll be slow, but we've been pretty good at finding solutions to those problems over time. I would like this is exactly the place, as an aside, where I really would like to use the two family folding. I think it would be pretty nifty if you like returned from the query system types with one family that is like not, that indicates that they're coming out of, they have not, I don't know what the word is, that they have bound types in them from their context, and then another one that instantiated them. On the other hand, if we start actually using binder, we sort of solve that problem a different way.
Yeah.
So, because that is a place where there actually are a non-trivial number of bugs due to people just forgetting to substitute when they should have done. And especially rustc's punning means that actually works a lot of times. Like, you have two contexts with two logically distinct type parameters, but both with index 0. And you should be substituting one for the other, but you don't. And it still compiles. And then someone makes a new example that has like not index 0, and everything breaks, and it's really confusing.
Yeah, I mean, even for doing like the chalk integration, it took me, I'm sure there's still bugs even after Matthew's fixed PR where I'd forgotten to substitute things, or just haven't. So yeah, I can totally sympathize with that.
All right, this is awesome. This seems like a workable plan. I don't know, what are we forgetting?
Yeah, I mean, I don't know. So what were the concrete steps here versus just try it?
Well, each of these bullets is like
the chalk side is concrete.
What's that?
The chalk side is a bit more concrete. But
yeah,
the rustc side is
version, yeah.
So let's see.
This is pretty concrete.
Yeah.
These are like two different PRs, and they're both pretty concrete.
Yeah. For the rustc, I don't know if we need to, like I said, I don't know if we need to revert back to kind without the method. I think the method will be on tie.
It is today, isn't it?
It's on tie s, which is slightly different, even though it's just a type alias.
One thing I want to add, which is related to all this, I do think we're going to want, I think eventually we're going to want some subtrait of interner that's like global interner. I don't know what it's called, but the point being that it's, or not global interner, that's the wrong name, but it would be a subtrait that allows you to get the interned representation without supplying the interner. And that would be useful for rustc. Rustc has that capability. And in particular, then we could implement deref for, if you have that an interner that meets that bound, tie can implement deref and deref to tie data just like rustc does. Yeah. And the advantage of that would be that then we can, not modify all the rustc source code that takes advantage of that. And it's more convenient when you can, and less convenient when you're writing generic code. And that's okay.
Yeah, but it would have to have like a different set of method names, right? Of function names.
Yeah, I guess, or they're free functions. So who cares?
Yeah.
Yeah, it's just a minor thing, but I'm not particularly keen to go and modify rustc so that we pass TCX in everywhere just to not use it.
Yeah.
It seems a little silly. And in particular, it would let the code that does stuff like, it would let us write code like tie.kind, like match tie.kind in rustc.
Yeah.
Again.
Well, like I said, luckily now it is a method, so it's easy enough to just
we can just leave it for now.
Yeah.
So yeah, to do it, we would want to add a conditional deref.
Yeah.
For interners which can access data. So speaking of interning, it's only sort of related, but it seems related. Rust analyzer, there was this stuff about that poor performance due to interning vectors and so forth, right?
Yes.
And
I don't know if we did anything. I don't think we've done anything to fix that.
I don't think we did anything. I feel like I don't really know what, like, I mean, I'm not sure what the right fix is for that. I'm not sure why that's different than rustc, apart from the fact that they use probably a naive data structure that does a lot more allocation. I don't, like, there could be two possible fixes, right? One would be that you just figure out that you can return the original value or do less folding.
Yeah.
And the other would be that you optimize the interning step. I think rustc is more on the latter, actually. I don't think we're all that smart about the former, but maybe we are in some places. Maybe there's a few crucial places.
Yeah,
some of these steps a little. But.
Yeah, it might be worth having someone dig into that. I haven't looked into it, but I agree.
Maybe we can ping Florian, be interested. Bold. It'd be nice to get someone from Rust Analyzer to do it. Although it might require some modifications to salsa. If we wanted, if the answer is that they should be interning their slices, we may have to modify salsa to do it. And rustc has some pretty scary code to do that, since I recall, like kind of subtle code.
Yeah. Yeah, I don't know. Is it slices that are cold or slow?
It's substitution, but you know what might also be true is that this may have changed. When you did the factoring to remove like type name, we now probably use a lot fewer substitutions.
Yeah, actually, that's a good point, because now we don't use it for any of the scalars. We don't use it for string, tuple.
Yeah,
well, no,
I wouldn't be surprised if this is actually less urgent.
That might be worth asking about.
Is our like weekly release thing still working?
Yeah, it's going.
Cool. Just pumping out, filling up crates. I hope. Good.
Yeah, and I mean it's also nice because we have the manual published too, because we just merged Matthew's fix and he did a manual publish, and now Chalk or rustc can use that. So speaking of which, there's a couple PRs for you to take a look at.
Yeah, please ping me.
Yeah, I will ping you.
I will try. I was so happy I got through. Well, I got through all my notifications because I marked them all as read. If they were more than like 3 days old, but I'm already behind again. Just the last 2 days. But I will try.
Yes, but yeah, the publishing works really well. There's only been a couple weeks recently, maybe just one, that there was like there's nothing between the releases. There's like no merged PRs, but I don't think it's not really a problem.
These seem like great candidates to me too, for people who want to get into Chalk.
Yes. I have to look at the tie flags PR and do a review of that. I was going to do it yesterday, but I got busy. But not really. Yeah, but that also sort of goes along with this.
What about these things? We didn't really talk much.
Yeah, we didn't talk about these. So the re-early bound, I think is going to go along with the tie param. Sort of, it's going to be.
That's what I thought too. It's kind of the same mechanism.
Refree, I don't know at all. I have no knowledge.
I mean, it's a weird version of replaceholder that we can put in query return results, basically.
All right.
Where do we use it again now?
When bound regions in function parameters inside the body, we turn them into refree.
Yes. Oh, what's the story with lexical region resolve at this moment?
It's still being used.
It just does.
Hopefully, I might get time to actually try getting those NLL errors to be good enough so that we can actually just not run lexical region resolve.
Is that the whole
from on
problem?
items.
The higher rank region errors are not great or something like that?
Yeah, the higher rank region errors which just don't tell you anything.
Okay. Because I feel like that was, maybe I'm wrong, but I feel like that's the major place that refree is still used. Is that true? Or are there other places where we use it?
No, I think it's just for lexical region resolve. It's also used when we record type annotations. We need to.
Oh yeah, we need to remember what the user actually wrote. Yeah. Okay.
Yeah, we
That's
could
annoying.
maybe use latebound regions.
Oh, that's so annoying.
But...
Okay. Yeah, we'll have to figure out a solution to that. Okay. Used in type body and for, sorry, in lexical region resolve and for user type annotation recording. So solution is improve NLL. It's such a yak shave. Oh my God. Higher ranked region errors so that we can remove lexical region resolve. And figure out something for user type annotations. Okay. And that was my least favorite part of NLL, was dealing with user type annotations. But for the rest of you who didn't suffer through that, the problem was that NLL completely erases, like, we basically don't have any region information, that we kind of reconstruct everything from the mirror. But that worked great, except for when users manually wrote things, like that has to be carried forward. Otherwise, we use nothing from the older classes. So if you like wrote let x ampersand tick a u32, in early versions, we just ignored this tick a altogether and just as if you didn't write anything, and that was confusing, of course. But, and it's super annoying. Lots of special case code just for that.
All right. So sounds like maybe there's a plan on the rustc side for that.
I think so. It's a bit of a long plan, but it may not be that bad.
Is it long as in after a shared type library, or
not necessarily?
It's not. It's just, I think I worked out a reasonable plan for this, and I just have been doing other things.
Yeah. Right. I don't think it's necessarily that hard, but it is also the kind where there might be surprises along the way.
Okay. Cool. All right, moving on. Yeah.
When do we think it makes sense to do? Like, I feel like we could start this now.
Yeah, that's a I think we can totally start it, or somebody can. It's just going to be trying to figure out as we go.
Yeah.
The problems that we might run into.
This is probably what's that?
I guess you can just start with like the various index types we have, which like require basically no effort, and then slowly build your way up towards tie.
Yeah.
Yeah. Yeah, there might be some. I mean, we could probably make the library and just pull out some like leaf types here or there that are going to want to be in there.
Yeah.
As a very first PR.
Yeah, I mean, I definitely, I would like it to be in small pieces, but I don't know how well that'll work because so much of it sort of interconnected that.
I feel like we'll find out.
We'll find out. Yeah, someone's got to play with it. I don't have time right now to, especially not with the Latebound region work that I'm doing. But if anybody is watching this and wants to try it, we're here to help.
So I'm going to say that I'm going to try this, and then you all are going to hold me accountable for whether I do or not. I'm happy to give it up too, but this needs a person to play with it.
Yeah.
This may need nothing.
Yeah. So for the DIN trait representation, how much does this overlap with just a general predicate refactor into like the chalk domain goal type style, or goal/domain goal?
Probably at least a little. Chalk also has where clause, right? If I remember.
Yes. Yeah.
At least that part would seem relevant, right? There are where clauses that don't. No, are there? Is there any form of where clause that cannot appear in a predicate? Maybe some of the weird ones. Like, I think maybe not actually, right? The only thing I can think of is we do have this sort of odd special case thing where I think you can write this like an empty list of region bounds, and it has some special case meaning like that the type is well formed or something. But it's not exactly special case, but it's kind of special case. My point being, if indeed existential predicate is just a binder of where clause, which I think is true, then there's a lot of overlap.
Okay.
And that would be a nice cleanup for rustc, in my opinion, or at least it could be a nice cleanup.
Yeah.
Yeah, okay, so this doesn't apply to DIN types, but otherwise it's true.
Yeah. And then
I guess you could go totally, I don't think we should. This is where I miss Scala. But in theory, it would be not like the real hierarchy would be like DIN where clause extends DIN where clause.
Yeah.
Something extends. I wish we could do that nicely in Rust, but we can't.
Trying to remember for the lowering, how do we handle that?
All right. This has been great. I think I gotta go because I have to do some chores.
Yeah, I think this has been super helpful. Yeah, I mean, most of this looks like there's a path forward, and I think a lot of this can be done sort of in parallel. So
yeah, it's exciting.
The only thing that I think is going to be really big and sort of in one glob, where most of it will be actually the extracting the library in rustc. But
yeah, I'm gonna just throw a link in here so I don't lose this hackmd. Reminds me, another thing we might do a meeting like this for at some point is revising the skill tree. But
I
don't know how important it is at this juncture.
I haven't looked at that in a bit.
Yeah, me either. I'd rather focus on this work, and we'll come back to that.
Yeah. All right. Well, thanks everybody for coming.
Yeah, this is great. I'll post this to the channel.
Nice.
Oh,
cool.
All right. Bye.
Bye.